Good evening everyone. So recall that in the last class we were discussing operator method. In operator method we discussed three methods. So operator method is mainly for computing the particular solution when P and Q are constant. So here we have to take P and Q as constant, and there were some conditions on f of x. So we discussed mainly the cases of successive integration and partial fraction. So where you have the form of 1 by d minus r1 d minus r2 and so on, and you can easily find the particular solution, and of course you can write d square plus pd plus q in the form of 1 by d minus r1 d minus r2 only if p and q are constants. So today we are going to discuss the new method, exponential shift rule. It says that if you have the differential equation of the form y double dash plus py dash plus qy is equal to e raised to the power kx and some function of x, yes, then how do we solve it? So using operator method we can write left hand side as d square plus pd plus qy. Now I am just considering a very special case when let's say p of d is d minus r, because we assume that we can always write p of d as d minus r1 d minus r2 and so on. So if I write it as d minus r f of x, then d minus r e raised to the power kx and gx. So I take d, which means d by dx, and r is a constant. So d by dx of e raised to power kx g of x would be as follows, and if you simplify it you will see that you can take e raised to the power kx common, and this become d plus k minus r g of x. It means that if I apply p of d to e raised to the power kx g of x, then I can simply write it as e raised to the power kx taking on the left hand side, and then replacing d by d plus k and applying p d plus k on g of x. Very interesting approach. The similar approach you can write it as, because when we are looking for the particular solution, then we have the form 1 by p of d f of x. So 1 by p of d e raised to the power kx g of x is equal to e raised to the power kx p of d plus k g of x. You may be wondering that in this step it is p by d, in the next step I simply did 1 by p by d. So here I have added the explanation on the right hand side, which is very easy to follow, and you will realize that if you have the result p of d, then the result can be easily obtained in terms of 1 by p of d. But the important point is the exponential shift rule, and it says that you have any function of the form, the left hand side should be a function with constant coefficient, but the right hand side is exponential function multiplied by any function of x, and you can solve it. But of course when you say any function of x, we should know technique to solve it or to find the particular solution using the operator method. So let's see the first example. Y double dash minus 3y dash plus 2y is equal to x e raised to the power x. Now you can see here that you cannot use method of undetermined coefficient, so only choice is variation of parameter. Now you can observe by yourself, you use the variation of parameter or the operator method, which works quickly. So your yp would be 1 by d square minus 3d plus 2 x e raised to the power x. Now if I use the exponential shift rule, then I must shift exponential function on the left hand side, replace d by, remember, d plus k. So here e raised to power kx, k is 1, so d plus 1 whole square minus 3 d plus 1 plus 2 and x. Yes, if you further simplify it, simply becomes e raised to the power x 1 by d square minus d and x. Now we know that how to use the operator method for the polynomial. We did it in the last class. There can be many ways for doing it. One thing is you can write it as e raised to the power x 1 by d minus 1 or 1 by d 1 minus d, taking minus outside, and x. Yes, so now I can use one of these. So recall the successive integration. I can use one at a time. Either you can use d first or you can use 1 minus d first, doesn't matter. So if I use 1 minus d first, then you will get 1 plus d square and so on x. This is minus e raised to the power x and 1 by d, and if you apply it, then it simply becomes x plus 1, and then you take 1 by d means the integration of x plus 1, so integration of x plus 1 dx, which is minus e raised to the power x square by 2 plus x. Yes, so very easy to use. One quick observation is that if here I applied 1 plus d square on x, instead of doing that, if I take 1 by d inside, then it becomes 1 by d plus 1 plus d. So instead of 2 terms which I got in the particular solution, you will get 3 terms. Yes, but the last term would be a constant 1 which is multiplied by e raised to the power x. Now this constant would be merged in yg. That's why both the particular solutions are correct. Please do observe by yourself. Let's do one more question. Please do try it by yourself. So again I want to use the exponential shift rule, so it becomes d square minus 4d plus 3 x cube e raised to the power 2x. So I take x raised to e raised to power 2x on that side. So d plus 2 whole square minus 4d plus 2 plus 3 x cube. Yes, now simplify it. So if you simplify it, becomes e raised to the power 2x and d square minus 1 x cube. Again x cube is a polynomial, so I have to use the geometric expansion. So I will write it as e raised to the power 2x and minus I can take, and 1 minus d square x cube. So it becomes minus e raised to the power 2x and 1 plus d square plus d raised to the power 4 and so on. So I don't need the terms d raised to power 4 and the remaining terms, only 1 plus d square would work. So this becomes x cube and d square means 2 times differentiation of x cube, which is 6x, which is the required particular solution. So again you can observe that it's very quick to use. The next is when f of x is e raised to the power ax. Now when it is an exponential function, we have already discussed the method of undetermined coefficient. So method of undetermined coefficient would work exactly as the operator method. So I am not discussing the detail, but quick observation is when a is not a root of the auxiliary equation, then you can recall that the denominator used to become pa, which means you replace m by a, m square plus pm plus q. So that's why 1 by p of d e raised to power ax is 1 by p of a e raised to power ax. It is same, either you use undetermined coefficient or operator method, it's same. If p of a is 0, which means one of the root of the auxiliary equation is equal to this is small a. In that case we used to do x e raised to the power ax, and in the denominator we used to write 2a plus p. So again if you differentiate d square plus pd plus q, it becomes 2d plus p, and if you replace d by a, it becomes 2a plus p. So again same, which we have discussed. And the last case is equal roots. So equal roots, again I am writing p double dash a. So recall that if you differentiate it twice, so 2d and again differentiate is 2, and that's why I used to get 1 by 2 x square e raised to the power ax. Recall that it's the same thing, x square p double dash a e raised to the power ax. So I am not going to the detail how we are obtaining it, but it works the same way as the method of indeterminate coefficients. So you can quickly see one or two questions and then we will proceed to the next case. So this says that solve or find the particular solution. So in this case your yp would be 1 by 4d square plus 4d minus 3 e raised to the power 2x. So I have to replace d by a. So this becomes e raised to the power 2x, 4 and then 2 square plus 4 into 2 minus 3, which is 1 by 21 e raised to the power 2x. The next is 1 by d cube minus 3d square plus 4 e raised to the power 2x. Again I will substitute d is equal to 2, so d is equal to 2 implies d cube minus 3d square plus 4 is equal to 0. It means I should consider p dash a. So p dash a means I should differentiate it. So x and its differentiation is 3d square minus 6d, and substituting d is equal to a because it's p dash a, and e raised to the power 2x. So that gives me, again you can observe d is equal to a means d is equal to 2, better to write 2. But again you will observe here that 3d square minus 6d is equal to 0 for d is equal to 2. So it means that you need to write it as x square e raised to the power 2x, again differentiating, which gives you 6d provided d is equal to 2, which gives you x square e raised to the power 2x. This is 6d minus 6, sorry, I cannot neglect that term, 6d minus 6 at d is equal to 2, so that gives you x square raised to power 2x by 6. Yes, if you solve it using undetermined coefficient also, it would take equal amount of the time. The last method is when f of x is sin ax plus b or cos ax plus b. So generally in determined coefficient we took it is of the form sin ax or cos ax instead of sin ax plus b. So in operator method, if I differentiate sin ax plus b, it is a times cos ax plus b. Double differentiation is minus a square sin ax plus b. And if I keep doing it, then you can observe that d square raised to the power n sin ax plus b is minus a square raised to the power n sin ax plus b, which is, it means that if I don't have to consider p of d now, because here d square is getting changed into minus a square. So instead of p of d, if I see it as p of d square, then to solve it I simply replace d square by minus a square. Yes, it would be more clear when we see an example. Similarly, in case of cos, it works in the same way, provided p of minus a square is not equal to 0. If p of minus a square is equal to 0, then 1 by pd square is x, 1 by p dash minus a square cos ax plus b. Now two important observation. In case of the exponential function, you have seen that I haven't wrote e raised to the power ax on the right and x on the left, because I am replacing d by a. So it means that denominator would be a constant only. But when I am replacing d square by minus a square, let's say I have d cube minus 1. So I replace d square by minus 4. So it becomes minus 4d minus 1. So then I have to solve it further. That's why I am taking x on the left hand side but keeping cos and sine on the right hand side. This is one observation. The other observation is, if you want to see how we reach here, then what you do is that you consider, instead of when p of minus a square is equal to 0, 1 by pd square cos ax plus b, you consider it as an exponential function e raised to the power I ax plus b, e raised to the power I ax plus b. Yes, when it becomes the exponential function, then recall that what used to be happen, you multiply it by x and consider p dash d, p dash a. So in that case, here you will consider p dash ia, because it's e raised to power ax, it is not e raised to power ax, but it is e raised to the power iax. And then in the end you compare the coefficient of sine and cosine, that gives you the required answer. Yes, I am not going into the detail, but if required I will add it into the notes. But here you just need to remember these two formulas and it will be more clear when you see some questions. So y triple dash plus y is sine 2x plus 3. So if I have to find yp, so yp is 1 by d cube plus 1 sine 2x plus 3. So recall that I should consider d square is equal to minus a square. So here a is 2, so this becomes d square dot d plus 1 sine 2x plus 3. Yes, now put d square is equal to minus a square, so it becomes 1 minus 4d and sine 2x plus 3. Yes, so sine 2x plus 3. Now you may think that you are stuck here because you do not know how to proceed further. You can only solve sine cosine when it is of the form d square. So the choice is again make it in the form of the d square by rationalizing it. So it becomes 1 plus 4d by 1 minus 16d square and sine 2x plus 3. Now again d square is equal to minus a square, so 1 minus 16 and minus 2 square sine 2x plus 3. So this would transform into 1 by 65, and I told you that I don't take sine or cosine function on the left hand side as in the case of exponential function, because I have to solve it further. 1 plus 4d and sine 2x plus 3. So d here is the differentiation, I know how to differentiate it. So 1 by 65 sine 2x plus 3 plus 4 times differentiation of sine 2x plus 3, which is 8, 4 multiplied by 2, and cos 2x plus 3. That is my required yp. So again you can see that if you use the method of undetermined coefficients, it takes lot of time. Using variation of parameter, even more than that, but using operator method it's very quick. Now see this question and try to first solve it using the method of undetermined coefficient, and then try using the operator method and see the difference. So using operator method, my yp is 1 by d square plus 4 cos 2x. Now if I put d square plus 4 is equal to 0 when d square is minus a square, which is minus 4. So in that case I used to consider x and then p dash minus a square. So p dash and minus a square cos 2x. So p dash d first I have to compute. This is x, and differentiation of d square plus 4 is 2d. Yes, where d square is equal to minus a square and cos 2x. Now you can multiply and divide by d, that gives you d square, but instead of that you can see 1 by d is simply the integration. So x by 2 and integration of cos 2x dx, which is x by 4 and sin 2x, so comparatively more easy. Yes. Now we have solved the similar question using method of undetermined coefficient using the method of superposition. So yg is simple, it is m square plus 9. So if I solve it, then it will get c1 cos 3x plus c2 sin 3x. Sin 3x. What I need is, I need yp1 for this one, yp2 for this one, yp3 for this one, and yp4 for this one. Again, I suggest that you must try it using the method of undetermined coefficient, and then you can try using the operator method and see which one works quickly. So for yp1, let me change the color. So yp1 is equal to 1 by d square plus 9 and 2 sin 3x. If I put d square plus 9 is equal to 0 when d square is minus a square, which is minus 9. So I will take it as 2x 1 by 2d sin 3x. So this 2 and this 2 would cancel out. The integration of sin 3x is minus cos 3x by 3. So it becomes minus x by 3 cos 3x. Very quick. Now let's do the next one, yp2. So for yp2 I have 4 sin x. So I will use the same technique, 1 by d square plus 9 and 4 sin x. Now d square is minus 1 because minus a square minus 1 square, not minus 1 whole square, minus and then 1 square. So it is 4 by minus 1 plus 9 sin x, which gives you 1 by 2 sin x. Again, see how quick it is. Then yp3, so yp3 is 1 by d square plus 9 and minus 26 e raised to the power minus 2x. Now in case of exponential function, it is simply you need to replace d by a. So minus 26 and minus 2 square plus 9 e raised to the power minus 2x, which becomes minus 2 e raised to the power minus 2x. The last is yp4, which is 1 by d square plus 9 and 27 x cube, exponential function. So what I do is that I take 9 common, 27 is here, and it is 1 plus d square by 9 x cube, which I write it as 27 by 9 is 3, 1 minus d square by 9 plus d raised to the power 4 by 81 and so on, and x cube. So now I know how to solve it. So 3x cube minus 6x by 9, that gives me 3x cube minus 2x. So it means my final yp is yp1 plus yp2 plus yp3 plus yp4. Okay, let's do the next or last question, which is very interesting. Now you can see the left hand side is not an equation with constant coefficient. Yes, but again if you use the variation of parameter, it takes a lot of time. But if you quickly observe, then the left hand side is an Euler equidimensional equation which can be transformed into equation with constant coefficient by substituting x is equal to e raised to the power z. So p minus 1 dy by dz plus qy is equal to 0. P is minus 3, q is 5. So this becomes d2y by dz square minus 4 dy by dz plus 5 is equal to 0. So auxiliary equation is m square minus 4m plus 5 is equal to 0. That gives you m is equal to plus minus 2y. Yes, so it means your yg is e raised to the power ax, so e raised to the power 2z c1 cos z plus c2 sin z. Z is equal to log x, so it becomes x square c1 cos log x plus c2 sin log x. Now point is, how do you compute yp? So for yp you need to see what is right hand side. So this right hand side, when you substitute x is equal to e raised to the power z, it becomes e raised to the power 2z and sin z. So it means yp is 1 by d square minus 4d plus 5 e raised to the power 2z and sin z. Now use exponential shift rule. So it becomes e raised to the power 2z d plus 2 whole square minus 4d plus 2 plus 5 and sin z. Yes, now it's quite easy. So it becomes d square plus 1 sin z. Now you can see that d square is equal to minus 1, that gives you determinant is equal to 0. So you write it as e raised to the power 2z, then multiplied by z, then 2d and sin z. So that gives you minus e raised to the power 2z, z and cos z, it is z by 2. If you transform it, it becomes minus x square by 2 log x and cos log x. So you can see that it was a very complex problem but can be easily solved using operator method. So thank you very much.